This lesson follows on from the previous one. We're still going to be doing some work on cumulative frequency graphs and box plots, but what we're going to do today is we're going to use those to compare two separate sets of data. So we're going to end up constructing cumulative frequency graphs and box plots for two separate sets of data, and then we're going to look at how we can use those to compare the data and what sort of things we can state in that comparison. So what I'm going to do first, you won't need to write any notes down on this. This is just really a recap of how to draw your cumulative frequency graphs and how to make a box plot. So if you've sort of forgotten any of this, it might be worth having a look back through your notes from last lesson, but this should all be a recap to you. So what we've got here is we've got a table of data. If you remember how you work out the cumulative frequency, what you do to work out these cumulative frequencies is you basically add up the frequencies as you go along. So that 8 in the first row means that there were 8 people, and this is to do with weights of people. There were 8 people who weighed between 0 and 5 kilograms. And then the 31 we get by doing the 8 plus the 23, and there were 31 people between 0 and 10 kilograms, 51 between 0 and 15, etc., etc. Now, if you remember when we draw these on our cumulative frequency graph, the really important thing to remember was where you plot these cumulative frequencies. And if you remember from last lesson, you plot them at the end of the interval. The reason being that 8 is a weight up to 5 kilograms, the 31 is a weight up to 10 kilograms, etc. So we plot those on our cumulative frequency graphs. So you can see that 8 is plotted at 5, okay, the 31 is plotted at 10, and we plot all of the others like that. And then we join them. Remember, you can either do a smooth curve or you can just join them with straight lines, which is usually what I find is a little bit easier. So that's what your cumulative frequency graph looks like. It always gives you this S-shaped curve. Remember, cumulative frequency on the y-axis, whatever it is you're measuring on the x-axis. Now let's remind ourselves how we can read off the median and the quartiles. Now the median, remember, that is the middle piece of data once they're in order. They're already in order because they're in this grouped frequency table. The total cumulative frequency was 72. So the median is going to be halfway up that, which is going to be the 36th value. So remember what we do, we draw a line across at 36, we drop it down, and then we read from our graph the value that that gives us. So for that particular one, that's going to be 11 kilograms, okay, and you do draw those lines on. If we look at the lower quartile is a quarter of the way up the data. So a quarter of 72, which is our total, a quarter of 72 is the 18th value. So if I draw a line across the 18 and I drop it down, and remember, draw these lines on so the examiner can see where you've read them from, then that reads off as 8 kilograms. And then the final one we do is the upper quartile, which is 3/4 of the way up. So 3/4 of the way up is the 54th value. We again draw our line across and we drop our line down, and that gives us the upper quartile of 16 kilograms. Okay, remember it's the difference between the upper quartile and the lower quartile which gives you that interquartile range. Remember what the interquartile range meant. That meant the range of the values of the middle 50% of the data. So we've ignored the smallest quarter and the biggest quarter, because remember that avoids those outliers, and the interquartile range gives us the range of the middle 50% of the data. Okay, let's remind ourselves then, it was number of dogs, there we go. I'll just skip past that because we're not bothered about that. Okay, right. So let's remind ourselves what box plots look like. Box plots, the box is made up of a box which goes from the lower quartile to the upper quartile. So the length of the box, here we go, the length of the box is your interquartile range. So a bigger box means a bigger interquartile range, smaller box means a smaller interquartile range. You put a line down for where the median is, and then remember where these whiskers go out. The whiskers go out to the minimum or the smallest value and the biggest value. Okay, right. So that should all be familiar to you. What we haven't done so far is looked at how we find medians and quartiles for what we call discrete data. So that's just for a list of data items. Okay, so what we've got here is we've got two sets of data. Let's look at the context. They're midday temperatures for Ringwood over the past 11 days and midday temperatures for Glasgow after the past 12 days. Now, if you remember if we were finding the median, the middle number, have a look at that data. What we're going to need to do first is we're going to need to put them in order. Okay, that's important so that we can find the middle one when they're in order. Now, we've got 11 data items here. So if I want to identify the middle one, because there is an odd number of data items, there will be an exact middle number. And what we can do is we can sort of tick them off either end, or we can just work out that if I have 5 one side, 5 the others, then the middle data item is going to be that 6th one there. Okay, so this is going to be my median. Now, when you have an exact middle data value, what we're going to need to do now is we're going to need to find the lower quartile and the upper quartile. Now, here's something important for you to remember. If you have an exact middle value, then I have in effect used that. So when I'm splitting the bottom half and the top half to find my quartiles, I basically ignore that data value. So I don't count that in what I'm doing. So when I'm splitting this in half again to find my lower quartile, I've got 1, 2, 3, 4, 5 data items. So the middle one of those 5 is going to be 16, and that's going to be my lower quartile. Notice I've ignored the median because I've used it because it was an exact value. When I'm doing the upper quartile, I'm finding the middle one of these 5 at the top. So that's going to be 20, and that's going to be my upper quartile. Okay, so when I have an odd number of data items, I pick out my exact median. I then ignore that when I'm splitting into the lower quartile and the upper quartile. Right, let's compare that then with the temperatures for Glasgow. Now, I've purposely given us an even number of data items. If you remember with data items, well, first thing when we find the median, I'm going to have to order them, so make sure you order them first. Now, when I've got an even number of data items, there isn't an exact middle number. So the middle number is going to be, so if I count 1, 2, 3, 4, 5, 6 there, and I draw a line down here, my median is halfway between these two numbers. Okay, so my median is going to be 17.5 because it's halfway between those. I've got 6 in the bottom half and I've got 6 in the top half. So notice there is no exact median. So now when I'm working out what the lower quartile is, I haven't got an exact median, so I've not used it. So I am now splitting all of this bottom half in half again to find my lower quartile. So how many have I got? I've got 6 data items. So again, I don't have an exact middle value. So my middle value is halfway between these two. Okay, now I didn't say you should be writing this down though, okay, as an example. So if you haven't been so far, pause it because this is something new and something you need to make sure you know how to do. Okay, so make sure you've got this written down. Right, so my lower quartile is halfway between these two, so that's going to be 16.5. That's my lower quartile. And my upper quartile, I'm using all of these 6 numbers, so my upper quartile is halfway between those middle two, so my upper quartile is going to be 19.5. So notice the difference between those two sets of data. When you've got an odd number of data items, you have an exact median. Okay, so you then take that out when you're splitting the lower quartile and upper quartile. When you've got an even number of data items, you don't have an exact median. It is in between those two. So then you use all of those lower 6 and all of those upper 6. Okay, right. Hopefully you're happy with that. Now what we're going to do then, it says draw box plots for both of them and use them to compare the temperatures in Ringwood and Glasgow. So on to the next page, I've got all of our values summarised here. You will already have those written down. Now we don't already have a cumulative frequency graph, so I'm going to need to draw a scale on which to plot my box plots against. So it needs to go from 13, which is the smallest for Glasgow, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, up to 24, which is my largest one. So let's just maybe 15, 17, 19, 21, 23. You can number all of them if you want to. Right, let's draw our box plots then. So we draw the Ringwood one first. So remember, the box is made up from going from the lower quartile, okay, to the upper quartile. So it goes from 16 up to 20. So that is where I'm going to be. You're obviously going to be using a pencil and a ruler. It will be so much nicer than my box there. That goes from lower quartile 16 to upper quartile 20. The median is 19, so I have a vertical line in my box at 19. Smallest value 14, so remember that's where my whisker goes out to. Biggest value 24, nice big whisker out that end, okay. And I'm going to put the fact that that's my Ringwood. Okay, so yours is going to look so much nicer than that. Right, let's do Glasgow then. Glasgow, the box goes from the lower quartile, which is 16.5, to the upper quartile, which is 19.5. That makes my box there. Median at 17.5, like that. Whisker, smallest value 13, biggest value 21. Okay, and I'm just going to write the fact that that's Glasgow. Now, when we were doing some comparisons of frequency tables a couple of lessons ago, we were talking about when we compare things, that we compare two things. We compare an average of some sort. So from our box plots, the average we can compare is going to be our median. So we're going to compare those two and answer in context what that tells us. We also compare a measure of spread. Okay, and the good measure of spread for us to compare is the interquartile range. And remember what that's represented by is by the length of the box. So the answers we give, we always write within context. So we don't say one's bigger than the other, we say what this means. Now back to the question. The question was talking about midday temperatures in degrees centigrade. So two things I'm going to write. Ringwood is warmer than Glasgow on average. What tells us that? The median for Ringwood is 19 versus the median for Glasgow is 17.5 degrees C. So Ringwood is warmer on average than Glasgow. Don't say it's bigger because these values represent temperature. So that is comparing my average. The other thing we're going to compare is how varied the data is, and that is represented by the interquartile range. So the temperature is more varied in Ringwood than Glasgow because the interquartile range of Ringwood, remember that's the difference between the lower quartile and the upper quartile, so that's 4. The interquartile range is bigger for Ringwood than it is for Glasgow. Okay, so we've said the temperature is more varied in Ringwood than Glasgow with an interquartile range of 4 degrees centigrade versus 3 degrees centigrade. Okay, so that is drawing box plots from discrete data. So do make sure you're happy how, if we've got all of the data items listed out, put them in order if they're not already in order, okay, and then make sure that you're happy with the difference between when you've got an exact median for an odd number of values as opposed to when you don't for an even number of values. Okay, right, let's go to something that's a little bit more familiar then. So this is the same as what we were doing last lesson, but we're just going to do two graphs and we're going to compare the two. So what I'll need you to do is to copy this down into your book. Okay, let's read the context. The table shows the ages that men from two professions spotted their first grey hair, teachers and doctors. Okay, so what we're going to do, copy the table down, pause it if you need a bit more time. We're going to fill in our cumulative frequency values. Now remember how you fill them out. You add them up as you go along. Okay, so there's 40 teachers, and the same with the doctors. We add those up as we go along, and again there's 40 doctors. Okay, so two things we're going to do. We're going to draw cumulative frequency curves on the same axes. Normally when you're comparing them, you do them on the same axes. Make sure you label which one is which. And then we're going to draw box plots underneath our axes, and then we're going to do a comparison like we did before. Okay, so think about what your axes are going to be. Cumulative frequency, y-axis, range of values, 0 to 40. X-axis is going to be the age, range of values. We can start at 20 if we want to, okay, and it goes up to 45. So your axes will look like this. Okay, I've just repeated our tables here so we can see where the information is coming from. Remember where you plot them. Okay, so the cumulative frequency plots at the end of the interval. So 5 will go at 25 for our teachers, 20 will go at 30 for our teachers, etc. So you're going to plot all those values for the teachers, like that, and then you're going to join them together. Okay. And then you're going to do exactly the same for the doctors. Okay, so for the doctors, that's going to be our green line. If you've got a couple of different graphs on your axis, then either a bit of colour or make sure you sort of label them. You can do something like write on it, like that one there is my doctors. Okay, if you haven't got colours, and that one there is my teachers. So make sure in an exam it's really clear which one is which. Okay. What we're going to do now then is we're going to read off our median and lower quartile and upper quartile for each of the graphs. So you have a think, median, halfway up the cumulative frequency, so that's going to be my 20th value. Read it off for both of them. Okay, teachers should be 30, approximately 30, depends if you've joined them with straight lines or curves. They might be slightly different to those, but you draw the lines on your graph and you write down what you get from your graph. Okay, lower quartile, that's going to be a quarter of the way up, so that's going to be my 10th value. Again, draw your lines on, drop your values down, read them off. So you should get 27 for your teachers and 29 for your doctors. And do the upper quartile. Upper quartile's 3/4 of the way up, so that's going to be our 30th value. And again we go across, and actually that's where the two graphs intersect. So actually our upper quartile for both of them is 34. So what you're going to do now then, underneath your axes, so we can use that X scale, we're going to draw our box and whisker plots. Okay, so here they are. This is the one for my teachers. Okay, that's going to be our box and our whiskers for our teachers. So notice it goes from, the box goes from the lower quartile to the upper quartile. It's got a line at the median, and the whiskers go from 20 up to 45. Exactly the same thing for your doctors. Okay, so notice with the doctors' values in the table, there were none in the frequency 20 to 25, so my whisker only goes out to 25, but again we've got them from the lower quartile to the upper quartile line at the median. Okay, so now we're going to compare them. Remember, two things we compare. We're going to compare an average. So from our box and whisker plots, the average we compare is the median. The median is the line in the middle of the box. Okay, so if you have a look at the line in the middle of the box, for the teachers it's lower than for the doctors, but let's put that in context. So on average, teachers go grayer at a younger age because their median is lower. Okay, and I would normally state what the median is, so I would say the median is 30 versus 32. Okay, and the second thing we do is we compare measure of spread, and that's indicated by the length of the box. So the box for the doctors is smaller. Okay, so that means there is less variation for the doctors. So within the context, what that means is doctors go grey at a more similar age. Now they've mentioned the range and the interquartile range. It's fine to just mention one of them or to mention both of them, but you can see for both of them, the whole range, which is the box and the whiskers, or just the box, is smaller for doctors than it is for teachers, but make sure you answer your question in context. Okay. Do make sure you've got all of that written down as examples. If you need to rewind, if you need to fast forward, if you need to pause it, that's absolutely fine. Just make sure you've understood how to draw those, okay, and also how to compare them. Remember, to compare, you want two different types of comparisons. You want one talking about on average, which is the median, and you want one talking about variation or how spread out the data is, which is your interquartile range. Right, so what you've got to do now is you've got a worksheet. If you can print this worksheet out, I've attached it onto Insight for you. If you print it out, then you can write all of your answers on the worksheet. Okay, I'm also going to attach the answers for the worksheet as well. So once you've done it, you can check your answers against mine. Okay, not going to ask for any of that to be submitted as evidence on Insight. I'm going to get you to submit evidence from the next lesson. Okay, so things to remember: do questions, oh sorry, I should change that. That should be do questions on the sheet. Okay, I will change that. Make sure you fill in the table on your sheet. Okay. And then for your graph, there is some squared paper on the actual sheet itself. Sorry, I changed this from what I was going to do. So make sure just fill it all in on the sheet. That's going to be easier for you to fill it in on the sheet, and then you can glue it into your book. Okay, when you're doing your comparison for the median and the interquartile range, always answer in context. If you have any problems with it, then you should drop your teacher a quick email just to say that you don't understand something, or rewatch the video, and then do make sure you mark your answers from the answers which will be provided on Insight as well. Okay, that's it. Thank you very much.